Okay, now we'll go through the two notations that you're going to be using to represent your derivatives when you differentiate, okay? We start with Leibniz notation, which is the more common one. It says if you have a function y, or your graph y being equal to, say, 3x squared. Okay, this is the original function or your graph, right? We're representing it as a graph here because it's y being equal to something x. You could plot this. So now, if I want to get the gradient function for this graph, if I want to get, or for this curve, if I want to get the gradient function, then I'll write it as dy dx, okay? And it will be now equal to 6x. I'll talk about the power rule in the next video. But now we're just looking at the notation. You write it as dy dx, okay? Dy dx, if you have your original as y. And you say it as dy dx, it's not dy over dx. This is the first derivative. If you want to differentiate the second time and get the second derivative, you now write it as d2y over dx squared, okay? So it's d2y dx squared. d2y dx squared, it is now just equal to 6. We'll differentiate, and that's what we get. Now for Lagrange's notation, which is also called functional notation. Remember, the first one is Leibniz. Okay? Leibniz. It's from a guy called Wilhelm Leibniz. Now here we are talking about Lagrange's notation. It's also called functional notation. If you have a function f of x being equal to the same thing, 3x squared, then the first derivative, or the gradient function, is written as f dash x. And it's a forward slanting dash. It's like it wants to fall forward. Okay? This will be equal to 6x. Okay? And this is now 18 because we've raised it to the power of 6. Let's just use that. It's now 6 times 3, 18x to the power of 5. Right? I'm just putting it in as an example. Then now I will get the second derivative, f dash dash of x. It is now equal to, this is the second derivative, okay? It is now equal to 90x to the 4. That is the final solution. And that is the two notations. We're going to be using them for first derivative and second derivative. So dy dx first derivative, d2y dx squared second derivative, f dash x first derivative, f double dash x, or f dash dash x, is the second derivative. And that's it. Now we'll see more on the rules and as we go on.